side. And at first we said, no, that's just an internal tool we have. But then after we decided to wind down Solano, we said, hey, maybe there's something here. I remember in June of 2012, we ended up making the decision to switch over full-time into building out this analytics platform. And that was the start of Amplitude. We launched the company in 2014 and have been growing since. To this day, in terms of folks who I know have my interests as a founder deeply at heart, like Paul Graham and Y Combinator is at the top of the list. Most of the time within YC, because we were working on Sonalight, was spent talking about, hey, how do we grow it? How do we launch it? How do we get more users on it? And we'd meet with them weekly about it. I remember this one conversation. Sam Altman was starting to get involved at the time because he had just wound down Looped. I remember Sam really challenged us about how passionate we were about this problem and whether we think we were going to be successful. And I remember saying to him, yeah, we're not particularly passionate users of voice recognition as a technology. We just think it's a cool technology. And he's like, yeah, you guys should work on something else. And so that was the genesis of us deciding to wind down Sonalight and then ended up working on Amplitude. One of the biggest mistakes we made with Sonalight was not spending enough time talking with our customers. We would build product because as engineers, that's what you know how to do. You know how to build product. How do you talk to customers? I don't know. It's weird. We just reached out to 30 other companies and to do research and to ask them, hey, is this a pain point? Would you use this? What are your pain points? How do you think about this in terms of how it fits in your business? And through that process, we actually found companies interested in as a founder, how do you spend half your time interfacing and really understanding customers? It's so easy to do other things. It's so easy to, if you're an engineer, build product. It's so easy if you're a designer to spend time on that. But it's very, very easy to not spend time on talking to your customers. And so as a founding team, you have to be very deliberate about spending 50% of your time engaged with users. Perfect, the enemy of good. My point there is that I think one of the mistakes people get into is thinking, hey, I don't want to let go of this idea. We were really in love with the potential of voice recognition. It was this new technology that was at the bleeding edge of what's possible. It was hard to imagine a future without it, very highly technical problem. It was what I'd call a 95th percentile idea. So it was in the top 5% of ideas. After doing it a year, you realize, one, we weren't passionate about the space, and then two, technology wasn't quite there yet, and so it wouldn't be possible to create a breakthrough. And so while it was a good attempt, we knew we could do better in terms of what we built. And so we got incredibly lucky. We searched around at a lot of different ideas, and we ended up zeroing in on analytics. And in retrospect, that was a 99th percentile idea for us. It was top 1% of ideas. First, there was a big pain out there. We knew that the web was shifting from a marketing-centric web to a product-centric web and would require a new set of infrastructure. And so what Google Analytics and Adobe had done in the previous generation would need to be redone. There was an opportunity to build something massive. The second is that we were the right founders for it. We were hardcore algorithms engineers to figure out how to create a system that successfully processes massive volumes of data and spits out a result was perfectly in our wheelhouse. The opportunity was there, and it was a great match for who we were as founders. I think of that as a 99th percentile idea, and I'm so glad that we made the decision to wind down Sonalight as a result and go after something great. You often want to just go build something, and building stuff is great, but you also have to ask yourself continually the question of, am I building the right thing? I regret it in retrospect. We should have been able to launch in 6 months instead of taking a year and a half. I made such a big mistake. I stopped talking to users in the middle of it, and we just focused on building. And as it turns out, there were a lot of people who would try it out and use it for free, but none of them were actually interested in paying us. And it wasn't until July of 2013 that I actually got our first customer to agree to pay us. And I should have asked for money much earlier, because then I would have realized we weren't talking to the right companies. I remember I was in a meeting with this company called Super Lucky Casino, very first Amplitude customer. And I went through the demo and the pitch, this guy named Brett Taylor, and we got to the end of it, and he asked me a question I'd never been asked before up to that point. He asked me, how much does the product cost? And I'm like, what? I don't even know what to answer. I've always just given this away for free and assumed people would use it for free. And then I remember the advice of Patrick McKenzie, who says, always charge more for your product. And I thought I was going to charge maybe $50 a month for this thing. So I'm like, you know what? Let me double that. And let me ask him for $100 a month. $100 a month is enough. Let me 10x that. Think of the biggest number I could think of, $1,000 a month. So I said, $1,000 a month is how much it costs, with as much confidence as I could muster. And to my surprise, he was like, okay, we'll pay for it. And I'm like, oh my God, holy smokes, someone actually wants to buy the software we had built. All my dreams of building software that we could charge for it and got validated in that moment. We're like, wow, I can actually build a piece of value that someone wants to buy. This is incredible. And then we launched the product 6 months later in 2014. So in retrospect, I should have been asking for money way earlier for all those customers. I would have gotten a lot of no's, but that would have been okay. I would have gotten much faster to someone like Brett and realized I should have been out there trying to keep finding someone until I found someone with enough pain on this that I could get them to pay us money. I was afraid because I knew they would say no, or I had suspicion they would say no, and I wasn't confident enough in my heart. Yeah, as we build it and make it better to what you want, you're committing as well with the investment that you're making in it. Frankly, a lack of confidence in the product. It was a lot, and instead I should have known, hey, it's okay to have an early stage underdeveloped product, and it's okay still to ask for money for it, even if it's in that state. And you're going to get a lot of no's, but you don't need, it doesn't matter how many no's you get, you only need one customer to say yes for you to actually build a business around it. And so I would have, understanding that, how to work that dynamic earlier and just focus on companies who are willing to pay you money would have been allowed us to much more quickly get to the state where we focus on customers that actually were interested and had the pain enough to pay. So after that first customer, Super Lucky Casino, they introduced us to other companies. Brett was an ex-product manager from Zynga, and he had a lot of other former product managers from Zynga who were used to having this sort of data and insights, and who didn't now that they were off at other companies, but who wanted that. And so he ended up introducing us to Siki Chen, who was running this company called Hey, and then a bunch of other ones. And we started to grow within that community. Finally, in February of 2014, we launched the product for the first time. I don't know how they found us, but somehow they saw this TechCrunch article and they're like, let me reach out to you guys. And so we're like, cool, okay. And then they ended up paying us $3,000 a month. And it was like, okay, wow, a legit company wants to buy us. And then it just started snowballing from there, where customers were to refer other customers. We would spread as a product. Okay. At the beginning, what was funny was the landscape was very crowded. There were tons of analytics companies that all did similar sounding things. Google Analytics was the biggest and the default thing you put in there. But there were lots of others too. The list just went on and on and on. There were probably 20 or 30 companies in this space. So it was a very, very crowded space. The thing we saw when we looked at it is none of them went deep in the problem. So they all did surface level metrics and then stopped there. And we said, hey, if we go much deeper, we think there's a ton of value and you don't have to scale off as you grow, either because you can't get to the data volumes or you can't get can't get to the depth of insight that you want to. Most companies don't use this software yet. Most companies don't understand what their users are doing in their product. It's like a black box that cannot see through. Our goal is to open up that box and help everyone see what's going on so that they can understand that experience and create a better one. We grew from 0 to 1 million in the first year, then from 1 to 4.5, then from 4.5 to 14, then from 14 to 31, then from 31 to 53, then from 53 to 80, then from 80 to more than 100. We launched it, started 2014, and we got to 100 million by the start of 2020. So it was about a 6-year journey in total, end to end to make that, which is feel incredibly lucky to have hit that. In terms of when you're going from 0 to 1, you're just begging anyone to use the product because you don't have much of a product or a brand or anything, be a customer base, or you don't have that much advanced knowledge of a problem, and so you're trying to consistently pull off miracles. And so would spend my time going out and talking to customers directly. I was full-time on the sales side, just trying to find opportunities for us to have as customers. And so we would commit new parts of the product. We'd say, hey, if you buy us, we're going to build this, this, and this. That was the core part of the motion because there was nothing there. And so you kind of had to just agree to whatever a customer wanted in order to get them on and get to from 0 to 1. Once you get to 1 million in ARR and to go from 1 to 10, you have a kernel that's working, and it's all about just trying to do the same thing. You still have to do some of it, but then it starts to pick up a momentum of its own. It's not constantly pushing it. There's some momentum it has. Once you get to 10, stuff starts to break down a lot, because what worked in just like doing heroic efforts in single deals does not work. You need to build an organization. You need to build repeatable processes and scale. And so you need to start to bring in outside executives who work on taking the thing you had and build scalable programs. Another salesperson on this, how do you enable them? How do you track and forecast so that you can have good forecast accuracy? How can you manage the creation of pipeline regularly? So you're always taking something that's a miracle you'll pull it off, and you're figuring out, okay, how do I replicate this in a much more scalable fashion? It's crazy. It's still surreal. I don't believe it. I'm way more successful than I ever thought we'd be. I feel so lucky that we were at the right place in the right time and tried to work on this in the right way. And so I feel incredibly lucky to be here. And so now what I'm focused on is making sure we don't waste the opportunity. We're the leader in the market that we have. We have this promise of how we can go take over things. I'll tell you a bit of inside's secret about it, which is that no matter what size you're at, you're always expected to grow more. So everyone wants to know, how are you going to be 10 times bigger than you are today? Even Google gets that question. Even if you're as successful as Google or Amazon or Microsoft, they want to know how you're going to be 10 times bigger. It's both a blessing and a curse. It's a blessing in that there's always an opportunity to do more, but it's a curse just when talented people, you get the knowledge of being in the market, you have a brand, you have a product, you have customers, but there are also parts that get harder. It's hard to run a large organization and be agile. It's hard to make sure you don't get too in your own head, full of yourself, and aren't in this next. It's still start the age. You can start in your 20s, you can start in your 30s, you can start it in your 40s or 50s. Like, any age is possible. The key thing to understand is how hard it is and how much of a life commitment it is. I've been very deliberate about sculpting my entire life to allow me to build this company. And so that extends to my personal life. That extends to where I live. That extends to what I think about. I just obsess about what I'm doing here day in, day out. And so you have to be in a spot in your life where you don't have anything else going on. My number one advice would be understand that it takes work. Then, or if you have other constraints or other things happening in your life, like, very candidly, look, I've fallen out of touch with so many friends because I'm so focused. Many fields, and there were three big ones. One was 10,000 hours of practice, the second is expert coaching, and the third is enthusiastic family support. And so I thought a lot about, hey, how do you set up all of those? Like, you need to spend a lot of time on it. You need to go get help from other people who are really good at this so you can learn much faster. And then you have to set up your personal and family life in a way that supports this. What's tough is a lot of people are not in the place in life. Spend lots of time where you can get coaching from experts and where you can get the support of your family. Then I think it's
us. We got the date and the time, and it's coming from the user Tommy and the room.
This comprehensive course is for absolute beginners. It will teach you back-end development with Python. Learn the basics of Python and a few projects along the way. Tommy has created many popular courses, both on his own channel and on the free CodeCamp channel.
Hi guys, welcome to this backend web development course with Python. In this course, we're going to be learning everything you need to know to start your web development journey with Python. Let's take a quick look at the agenda of this video. First, we will start from learning Python, which is the programming language we're going to use in this video. In the Python tutorial, there will be lots of exercises in which we're going to do together just to get comfortable with the Python programming language. In the tutorial, we will learn all the concepts you need to know while getting started into Django. After that, we're going to build 3 different projects using Django. The project we're going to build are a blog application, a weather detector program, and a real-time chat application using Django. We're going to build all these projects so you get familiar with building your own projects in Django. After that, you are going to get introduced into APIs with Django. You will learn how you can build REST APIs in Django using the Django REST framework. And I hope that after this video, you'll be comfortable with building your own server-side web applications using Django. Now I have some free resources like a Django roadmap, a Python data structure cheat sheet, a Django cheat sheet, and plenty more free resources in which I compiled into a PDF, and you can download that PDF for free using the link in the description below. And if you like more tutorials like this, you can also check out my own channel at Code You Told Me, where I teach more Python and web development in general. Now, having all this said, let's dive straight into this video. This tutorial is a Python full course where I'm going to be learning Python programming from scratch. So this is a list of everything we're going to be talking about in this video. So let me give a brief introduction to Python. So Python is one of the fastest growing programming languages in the world. With Python, you can go into various fields like machine learning and AI, web development, and plenty others. So taking to learn this course and choosing to learn Python is a very good decision for your programming journey. So without wasting any time, let's get straight into the tutorial. So right here, I'm just on my browser. So we're going to download Python on our laptop. So to do this, I'm just going to search for download Python for Windows, since I'm on a Windows. And then I'm going to click on the first link. And then right here, I see download Python 3.9.1, which is the latest version. So I'm just going to click on it. And then you can see here that it's downloaded it automatically. So I already have Python downloaded now. What I just need to do is to install it. So I'm just going to come into where I saved it, and then I'm going to run it. So make sure that when you are installing Python, you must tick this add Python to path. If not, you're just going to make it more complex than it's supposed to be for you. So let's click install now. Yes. And so this is just going to install Python on our machine. It should take a few minutes, a couple of minutes to install, and I'm going to be back when it's installed finish. So right now the setup was successful. So as you can see, the installation has been done. So I can just click on close. Now for me to confirm if I have Python installed, I'm going to open up my command prompt. So here in my command prompt, I'm just going to type Python. Once I type it, you should open up this shell. You might not understand what all this is now, but this is just to verify if Python was truly installed. So now that we know we have Python installed, let's just go ahead and install our code editor. So Python is the programming language, but where we're going to code, where we're going to program everything, or the Python we're going to do is going to be in a code editor. And there are various code editors out there. We have Visual Studio Code, we have PyCharm, we have Sublime Text, we have Atom. There are countless out there. But for this tutorial, we're going to be using Visual Studio Code. So let's go ahead and download it. So I can close up my command prompt right now. So let me just say that if you don't know how to get to your command prompt, you can just search for it on your Windows search bar. So right here, we can just go back to Google, and then we can search for, let's say, download Visual Studio Code. And I'll just click on the first one. So since I'm on a Windows, I'm going to download the one for Windows. If you're on Ubuntu or Linux or Mac, download the one for your OS. So right now you can see that it is downloading. So I already have it downloaded. I have it on my PC. I'm just going to cancel that since I already have it downloaded. Let me just show you the installation process. So right here I have it downloaded already. We just click on enter. That's to run it. So what it tells me here is that setup has detected that Visual Studio Code is running. So this simply means that I already have Visual Studio Code installed on my computer. So I'm just going to press cancel. But for you as a beginner, you want to install this as a new software. So when we already have this installed, we're just going to open up our Visual Studio Code. And this is what it should look like once you first open it up. So now we have everything set up. We downloaded Python and installed it, and then we downloaded Visual Studio Code and installed it. Now we can go straight into coding. So now that we have everything installed, what we just want to do is to create a new file. In this file is where we're going to code all our Python. So in Visual Studio Code, we're just going to come into the toolbar and click on New File. So once we click on New File, you can see it automatically has this untitled name, but we want to save it by pressing Ctrl S, and I'm just going to save it. First of all, let me say all files, and then I want to save it as app.py. So the name of the file is app, but at the bottom at the file extension I used .py. So anytime we're working with Python, anytime we want to create a new Python file, it must always have the extension .py. That will make whatever we're running on know that we are using a Python file. So now once I save it, it's updated here, and as you can see, Visual Studio Code automatically detects the logo of Python. Now that's how to create and save a new Python file. So this is basically how everything looks like in Visual Studio Code. On the left hand bar, we have a folder bar. That's where if we are opening a folder, this is where we're going to see all the files and folders in there. We have this search, this GitHub. We don't need to bother about that for now, but this is how Visual Studio Code looks like. So since we have everything, we know how to create a new file. What we want to talk about now is the print function. So in Python, we have some built-in functions. That means some things that are already done automatically, which we don't need to write too much of code. Now let's say we just want to print text to the screen, like we just want to show a user like hello world or welcome. We're going to use the print function. You're just going to print a basic text to the screen. Now for us to do this, we're going to say print, and then we're going to open parentheses, and then we can use single quotes or we can also use double quotes. There is no problem here in Python, but we can just go with single quotes, so you can just pick one and go with that. So in this code, I'm going to write my text, and I can say hello world. Now as you can see, I have printed hello world, and I must make sure I save this file. And then for me to run this Python file, for me to see the output of my code, I'm going to have to come to the right hand corner right here and click on run. Now once I click on run, you see that it opens a new terminal automatically, and our code is going to be run in this terminal. So if we just wait a second, we're going to see the output of this code. You can see right here that we have hello world. Automatically it prints hello world. If I say hello world welcome and I run it, you see it changes and it says hello world welcome. So that's how to run a Python file. Now let's talk about some more features about this print function. Now let's say we want to print on a new line like hello world, and we want this welcome to be on another line. We can easily do that. We can just remove this, and then on a new line we're just gonna print welcome, exactly the same thing. Now once I run it, you can see it says hello world down here and it says welcome. So that's how to print on a new line. We can also do a lot of things. Let's say we want to add another value to this hello world, like let's print a sentence. Let's say my name is Tommy, and then I want to say my age is Then I can add a comma right here and say 100. So this will automatically tell Python that this is a number and it's no more a string, just a normal character. So now once I run it, you're gonna see it says my name is Tommy, my name is 100 with no errors. And automatically you see that it leaves a space right here. Right here we didn't leave a space, but automatically once we put this number here, it leaves a space. To clarify that, if I put don't leave no space and I run it, you see that the space is still there. So that's just a smart feature of Python. So I think that's gonna be all for the print function. Now let's talk about variables in Python. As you can see here, I have 3 print functions. The first one says Tim is a boy, the second one says Tim is 18, and the third one says Tim is from Turkey. So as you can see, in the 3 print functions, I'm repeating Tim 3 times. Now we can use variables instead of repeating a particular text. Now variables are just basically saving a data in the memory of Python, and then we can get that data back by referencing its name. So let's see this in action. Let's say above the code, I have a variable named name. So this name is the name of the variable, and I'm saying equals to, I put single quotes, and the name is Tim. So name is the name of the variable, and Tim is the value assigned to this name. So like this, we've saved this variable up here. So we can print that variable. Once you say print, whenever we are printing a variable, we don't put quotes like we do when we are printing a normal string. So we can remove the quotes and just type the name of the variable, which is name. So now when I run this, you are going to see it prints all this, and on the 4th line it prints Tim. It didn't print name. Now this is what variable is about. It's just basically saving a particular data and then referencing it through the variable name. So now instead of saying Tim 3 times, we can just replace this Tim with name. And for us to do this, right here you see we printed only the variable and we didn't have quotes. But right here we are printing string with quotes, and we also want to print the variable with it. So this is called concatenation. We're going to join the variable and the normal string together. To do this, let's remove Tim, and we're going to say name, which is the name of the variable, plus the remaining text. Now once we say name plus is a boy, it's going to print us Tim is a boy. So we can also do the same right here. We just simply remove Tim and we say name plus is 18. We do the same for the 3rd line. We'll say name plus is from Turkey. Now once we print this, you can see it says Tim is a boy, Tim is 18, Tim is from Turkey. But right here we said name. So that's what variable is about. So let's just type CLS to close this up. But variable is more broad than just this. So there's something we call data types. Now as you can see, this is just Tim. Tim is letter, is a character, and that is a string. So string are basically just characters. Now string is a data type. We have, if this is a number like 23, is no more a string, is now an integer. We have Boolean, which is for true or false values, and others. But for this tutorial, we're just going to be particular about maybe 2 or 3. So now if I want to, let me just undo that. Let me specify a new variable and name it age. Now this variable, I want it to be the age. And let's give it 18. So whenever we are using an integer or a number, we don't add quotes when we are assigning the variable. You see right here we added quotes, and inside that quote we put Tim. But for it to be an integer, you will see that we do not add quotes. If I hover on this, you see that it says 18 is int, which stands for integer. And then Tim right here is a string. So now we can just join this by saying plus h. Now once we print that, it's still gonna give us, okay, so you can see now that it says can only concatenate string, not integer. So now there's a problem with Python. Anytime we want to concatenate a string with a variable, it doesn't an integer with a string, it doesn't work. So we can just solve this. Instead of using this, we can say comma h. Once we print this, you can see it says Tim is from Turkey. So let me close this up. Right here, we can see anytime we're concatenating with a string, it's possible. But when we are dealing with an integer, we can't use this plus. We have to use comma. And we can also use comma when concatenating with a string also. So this is the two things. We can use addition sign with only string, and then we can use comma with string and integer. So if I run it, it's still gonna work. Tim is 18. Now that's basically how to concatenate and join strings with variables. Now we're going to be talking more about strings. So strings are just plain text. So if I print something like print I, this is a string. String are just plain text. Now we're going to talk more about the features of strings, different things you can do with strings. Now let's say I say I put a full stop. How are you? Now once I run this, you see that it runs it on the same line, which is I, how are you? But if I want this to be on another line without inputting another print function, I can just simply use a backslash n. This is a backslash n. Now this is going to automatically take this to a new line. It's just like a break. It's going to add a break in between this and this. So now once I run it, you're going to see it says I, how are you? But we have this space here because of this. If I cancel that and I run it again, you're going to see we have I, how are you? So we can also print string as a variable. So let's say we have something named name, and the name is Tim. So this is a string, it's a variable, but a string type of variable. And then in print function, we can also print that string variable by just saying print name without quotes. Once we print it, you're going to see right here we have Tim printed. So let's just close this up. So if we come up here, we can also print, let's say we want to add a double quote or single quote. Now you know we can't add a single quote in between our text. That's because Python is going to see this like we want to close up this print text. So for us to add a double quote, we can just easily add a backslash, then the quote. Now once you have a backslash and that quote, this quote is going to be printed. Once I run it, you see now we have I with this quote, how are you? So if you want to print special characters, we use the backslash. Or you can just print the backslash alone. It's going to work. So you can see the backslash is there. So we can use the backslash to break, to make it on a new line. We can also use the backslash to add a quote, and then we can print the backslash just like that. Now let me talk to you about special functions on strings. So functions in Python is just a block of code which does a particular task. So in this string has a lot of function which does different things. Let's say we want to convert all the characters in this to uppercase. We can use a string function, or we want to check if it's lowercase, or want to get only the first letter or the second. Those are functions in Python. So now we can just say we want to get only the first letter. Now if we want to get the first letter, we can just easily do something like print name, the square bracket, and 0. Now 0 represents the first letter. If I say 1, it represents the second letter. If I say 2, it represents the third letter. So in Python, or in programming in general, numbers start counting from 0. So once I put 0 and then run it, down here you see it prints only T. Now let me run 2, which is the third one. You see it prints only M. And if I run what is not there, like 0, 1, 2, if I try to run 3, it's gonna give us an error, index error. So you can see string index out of range, which means it's not present there. Now we can also do multiple things. Let's say we want to convert this all to uppercase. We can just do name dot uppercase. Now once we run this, it says has no attribute uppercase. So sometimes we can run into error. We just change it. So I think it's because there's not supposed to be case. So name.upper is the function that changes it to uppercase. So once I run it, you see now that we have team in uppercase. We can also do the same thing with lower. We just say name.lower and then we run it. Now you can see that everything is being changed to a lowercase. Now once we come back here, we can also check if everything which is present here is uppercase or if all the characters are lowercase. So for us to do that, we're just gonna say name.isLower. So once I run it, you see it says false. So it's gonna give me a true or false response. If everything is uppercase, it's gonna give me false. But if it's lower, it's gonna give me true. So you can see, since there is an uppercase T here, I asked if it's lower and it says false. But if I ask if it is upper and run it, it still says false. That's simply because there is uppercase and there is lowercase. Not everything is upper or lower. But if I change it to a lowercase, let me change everything to upper, CIM, and then I run it, you can see now it says true because everything is uppercase. And then we can also join different functions together. Now you can see if I say something like is lower and I run it, it says false. But I can first of all convert it to lowercase, then ask if it's lower. So I can do dot lower and then run. You see now it says true, but it's uppercase. So first of all, it says name.lower, which means convert it to lowercase. Then it checks if it's lowercase, it gives us true. So that's basically how to just join different or add different functions together. And then we can also do something else by, let's say we want to get the amount of characters we have in this variable. To do that, we can say len, then we open a bracket and close it. When we run this, you can see it gives us 3 because we have 1, 2, 3. If I have a lot and then I run it, it's gonna give me 18, the number which we have in there. So that's how to get the length of a string. But let me just undo that. But let's say we want to find where a particular text is. So this is I. Let's say we want to get the index number of I. As we know, this is 0 and 1. So this I is index number is 1. If we want to get it, we're just gonna say len. We're gonna remove len. So we're gonna say name dot index, and then we're gonna say I. So now it's gonna print me 1 because that's the index number of I. Once I run it, you see it prints me 1, which is the index number. Now let's say we want to replace a text. Let's say where we have M, we want to replace it with T. So we can easily do that. What I'm just gonna say is name the replace. I'm gonna open a bracket, parenthesis, then the text to replace, we want to replace M, we're gonna put M, and then what we just want to do is comma, and then what we want to replace it with, we want to replace it with T. So now once I run this, you can see it's print TIT. So that is replacing this M with T. So that's basically how to replace. So there are also a lot of functions, a lot of string functions, but these are just some I showed you and how to use them. So that's gonna be all for strings. In this part, we're going to be talking about numbers in Python. So to print a number in Python is pretty easy. We just type print, and then we just go ahead and type the number 78. Now once we just run it, you'll see that it prints 78. So we don't need to add any syntax or anything. We just print 78 and it gives us 78. Now we can also specify a number as a variable. We can say no, the number is equals to 79. We just write it like that. We don't need to add this, and then we can print number. So once we run it, it gives us 78 and 79. Now we can also add numbers. So let me just remove this. So instead of just printing 78, we can print 78 plus 22. Now we can add a number, we can perform arithmetic operations. Once I run it, you see that it gives me 100. It automatically adds these two numbers or integers together, and then it runs it. I can also try this with a decimal number. Let's say 0.7 like this. Then once I run it, you see it gives me 100.934. So that is how numbers work. And we can also test it out with the subtraction. You see it gives us 55.066. And then we can test it out with the division. It gives us the answer. And then we can also test it out with the multiplication. When we run it, it gives us the answer. So that's basically basic arithmetic operation with Python. But we can go further, just the way we did with strings. We can go further and use the built-in number functions. So let's say we want to show the remainder of a division. So let's say something like 20 divided by 6. Now you know that this will give us 3 remainder 2. So it's gonna give us 3 remainder all of these. But what if we just only want to get the remainder? We don't want to get the main answer. We can just do 20 percentage sign 6. Once I run it, you see it gives me 2, which is the remainder. Now that's how to get the remainder of a division. We can also convert a number to a string. Now let me show you. Let's say we have this variable. We have this variable named number equals to 55. You can see that is a number, an integer right here. Then I can specify a new variable. I can name it number 2, and I want this number 2 to be a string. So I'm going to say string of number variable. So now if I over on this number 2, you're going to see that is a string. When I print number 2, it's going to print 55, but now it's a string. It's 55 also, but it's a string. So how do we know if it's really a string? Remember that when concatenating, you can't concatenate numbers, but you can concatenate with string. So let's try to concatenate. So right here, let's say number is, let's try to concatenate with the main number. So let's say add number, and let's run it. You see it gives us an error, can only concatenate string, not integer. So but now that we've converted it, let's try to concatenate with num2. Once we run it, you see now it gives us number is 55. So that's to show that it has converted that integer or that number to a string. Now Python sees that as a string. This is also very useful in a lot of cases. So that's that. And then we can also get the absolute value of a number. So let's say, let's just cancel all this. Let's print -5. Now obviously when we print this, it should give us -5, as you can see down here. Let me just close this up. But if I wanted to print only 5 regardless of the sign, if it's positive or negative, I'm going to add ABS. Now this is a function, it's a number function. As I explained earlier, function is just a block of code which does a particular task. Now we can write a function manually by ourselves, but Python has some built-in function which we can automatically use. That's why when we use ABS, it automatically sees it as a Python function. Now this ABS means absolute. That's the full meaning of ABS. So it's going to get the absolute value of this number. Now when I run it, you see it prints only 5, regardless of this negative sign beside it. So we have 4 and 2. So now you know that 4 is obviously greater than 2. So once I print this, it's gonna give me 4. This is showing the highest number.
I know you peep the lights that are blinkering.
Of this. So that means 4 raised to power 2. Not 4 raised to power 2, sorry about that. This means we have these two numbers. Max is gonna get the highest number. So let's say we have another number named 3. Once I run it, it still prints 4 because 4 is greater than all of these. But now what if I have 16? Once I run it, it gives me 16 because 16 is the highest number in this range of numbers. I can also do the same to get the minimum amount of numbers. I can say min, so that is going to automatically print 2 because that's the minimum. So once I run it, you see it prints 2. So that's the basic way of getting the maximum and the minimum. And then we can also round a number too, so we can estimate a number. So you know, in normal mathematics, if we have something like 3.2, this is estimated to 3. But if we have something like 3.5, this is estimated to 4. We can also do this here in Python. For us to do this, we just say round. If we round 3.2, it's gonna give us 3. But once we round 3.5, it's gonna give us 4. Just normal estimation rounding off to a number. And then we also have one which is bin. Let's see, bin. So what this bin does is that it converts a particular number to a binary string. Now if you know binary numbers is this weird type of text. So each number has its binary string. So if you want to get the binary string of a number, you just run it and it prints this. Now let's run something like 334. It prints the binary string for 334. Now that is some basic functions, but there are countless functions for countless number functions. So all these we're not able to access them because they are already built in Python. But there are still more that we can't access except we import.
Now there's something in Python called import. Now we have more number functions, the one that can be able to find the square root, the one that can get the power, various are countless. So now the reason why we can't access those ones because we haven't imported them. The ones I just show you, we can use them without importing. But the ones I want to show you now, we need to import them from the Python math function before we can use it. So for us to import, we're going to say from math, something like this, import all. But instead of writing all, we write asterisk. So what this is doing is saying from the math class or the math function, import everything which is there. Now in this math class or function, there might be the one that can find square roots, there might be the one that can find the power, everything. So we don't know the one we want yet, so we're just importing everything with this asterisk. So now we can, since we have this imported, we can find the square roots. Now we can just say square roots of, let's do something like 100. And once we run this, it will give us 10. As you can see, it gives us 10. It added this 0.0. It's okay, but now it gives us 10. So that's gonna be all about working with numbers. So in this part, we're gonna be getting users input. So what we're gonna be doing is to tell a user to input a text, and then we're gonna save that text in a variable, and then we're gonna tell the user what he input. So let's go ahead and practicalize that. So to use an input in Python, it's pretty easy. We're just gonna say input, then open and close parentheses. Now with this open and close parentheses, we're gonna ask the user what we want to input. So we're gonna put the codes, and in that code we're gonna say, this is something like input your name. So now this is going to tell the user to input your name, and then once the user type in something like Tim or Tommy or John, anything the users type, we want to save it in this variable called name.
So now this variable called name is going to be the input. So now let's try that. We run it. You see now the first thing it says is input your name. Let me say Tommy. I click it. So now that's and just print name. So let's run it. Once the user inputs name and say Tim, you see that it just prints Tim. So we can make this more interactive by asking for the user's name and maybe asking for the user's age, and then telling the user your name is this and your age is this. So we need to have two variables. The second one will be age. So name equals input your name, and then age equals, and then we just want to add the name, and then we close that, and then we'll say and you are old. We run it says let me say John, and is 105 years old. So it says your name is John and you are 105 years old. So this is basically how to just collect simple data from the user and then use it the way you want. Tell the user your name is this, your age is this. So this is the basic concept. You can also link it with how they do websites, like when you create or sign up to a website and then they save that your name, your email and everything in the database, and they later tell you welcome John or welcome whatever your name is. So just we can link that concept. It's basically just getting a user input and then storing it as a variable, in this case as a data, and then we can print it to the user back. So that's all you need to know about getting users input. But we can also make it more fun. Now when we get a user input, you can see that the age is seen as a string. Right here you see age is string, but we want the age to be integer, so we can convert this string into an integer. So for us to do this, we're going to say int, we open the bracket and then we close the bracket. So everything is inside this integer function. If I come back here, you see now that it has been changed to integer, no more string. But now if we try to run this, I input my name and I input a random age. You can now see it gives us this error, can only concatenate string, not integer. So for us to be able to add age, you know what we need to do? We need to either convert it to a string, which we don't want to do, or we can just use comma. So let's just remove this and then let's run it. So let's input a random age right here, random name and age. So now you see it works. It says your name is John and you are 13. Now that's how to basically just get user input, use it how you want, and then you can pass the information back to the user. In this part, we're going to be doing a simple Python exercise. So what we're going to be doing is a simple word replacement program. So what is going to be happening is that a user is going to input a sentence, and then let's say user wants to change a word in that sentence or change something in that sentence, then we're going to allow the user to be able to do that. So if a user inputs a sentence like I am a boy, and he later wants to change that boy to, let's say, a guy or something else, so that's what we simply want to do. So we're going to ask the user for 3 inputs. The first input will be the sentence, the second input is going to be what the user wants to change, and then the third input is what the user wants to replace it with. So let's get that and practicalize it. Now the first thing we're going to do is just to have those variables. So let's first have a variable named sentence, and I want this variable to be an input, and then I'll just say enter your sentence. Now let me just print the sentence to the user. Let's run it. Now let's say the sentence is I am a boy, and you just simply print that sentence. We can come back here, let's just say your sentence is I am a boy, which is gonna be whatever the user writes. So then what we now want to do is to have another variable, let's say word 1. It should be an input. Now this variable is the word the user wants to remove or replace, and then we can say enter word to replace. Let's say the word to replace, and then once we have that, it's going to be stored in this variable named word 1, and then we're also going to have another variable, let's name it word 2. This is going to be what the user wants to replace it with. So let's say enter the word to replace it with. So now once we have all this, we're just going to print sentence dot replace. That means we want to replace this with this. Open the bracket to take 2 inputs, which is word 1, the word we want to replace, and then word 2, what we want to replace it with. So what this is doing is that, let's say we have a sentence named I am a boy, then this word 1 is the boy we want to change, and then word 2 is what we want to replace it with. So let's just go ahead and test it. So right here is running. Okay, it gives us invalid syntax. That's because we forgot to add a plus right here. Now let's do that again. Right here you can see it says enter your sentence. Now let me say I am a boy. Now it prints us your sentence is I am a boy, and it says enter the word to replace. So I want to replace this boy and enter the word to replace it with. I want to replace it with dude. Now you see it prints I am a dude. So that's basically how to do a simple word replacement exercise. It takes in an input, which is a sentence, and then it takes us another input, which is what we want to replace, and then the third one is what we want to replace it with, and then it basically just prints that to the screen. So I hope you understood what we did in this part. If you didn't, you can just go back and watch this part again, and then make sure you understand before moving to the next one. So in this part, we're going to be talking about working with lists in Python. So when you're working in Python, you're going to be dealing with a lot of data, and you want to be able to know how to fix the data into a list. So a list in Python is basically just a list of different attributes of different values fixed into a variable. So let's just dive straight into the practical. Now to define a list is similar to defining a variable. So we can just give it a name of a list. Let's say a list of countries, and I can name the list countries, and I'll just use the equal sign and the square brackets. When we are defining lists, we need to use a square bracket, and I can just give it some inputs like United Kingdom, and I can also give it another list like say Ghana, and let me say Nigeria. Let me give it one more value, and I can say Australia. So now this list, a list variable, it has 4 values. So now once I print the list like this, I'll just say print, and I'll give it countries, which is a list. You see that it just prints me the whole list the way it is right here. So that's basically the main thing you need to know when defining a list. But list is more broad than this. There are lots we can do with lists. Like let's say I just want to get the first attribute. Now each list has their index number. Like this is 0, 1, 2, 3, and so on. Just the way I said earlier in this tutorial that in Python or in programming general, number zero, so the index number of this value is 0, 1, 2, 3. It's just similar to when we have a variable. Let's say we have a variable named name, and we have Tommy. So this has an index of 0, 1, 2, 3. Now that's very similar to a list. Each value has an index of 0, 1, 2, 3. Now we can just delete that. Now let's say we only want to print this. We don't want to print the whole list. I can just do it like this. Countries with square brackets, and I'm fixing the index number in between the square brackets. Now when I run this, you see now that it prints me only United Kingdom. I can also do the same thing. Let's say I want to print Nigeria. I give it 2. I run it. Now you see that we have Nigeria. There are a lot of things we can do. Now let's say once we get this, we just want to print only N from it. We can also do that. So after saying countries index number 2, we can specify another index number saying 0. So once I run it, you see it prints me N. Now what does this mean? It says countries get the value with the index number 2. 0, 1, 2. So now it has Nigeria. And then I say from that Nigeria gets me the one with the index number 0. And then you see in Nigeria, N has the index number 0. So that's basically how to just add some simple things in Python lists. Now let's say we just want to get only all the lists from Ghana to the end. We don't want to add United Kingdom, or we just want to get the list from Nigeria to the end. We can also do that. So we just say countries. If we want to get from Ghana to the end, we can just say our square bracket 1 and a column. Now this is gonna get everything from index number 1 till the end. Now let's make sure we close this. When I run it, you see now it gives me the list without United Kingdom. That's how to just get it from a particular index number to the end. We can also do the same thing. We can say from 2, you'll see that it gives me from Nigeria to Australia. Right here, Nigeria and Australia. Now I can also specify a range. Let's say I only want to get the list from 1 to 2. Okay, let me add one more value here. Let me say New Zealand. Yeah, so right here I say New Zealand, and this is 0, 1, 2, 3, 4. Let's say I only want to get from 1 to 3. I don't want the last one, and I don't want this. I can easily do that. I'll say from 1, which is from Ghana, index number 1. Then after the column, I'll say 3. So 1, 2, 3. Once I run that, you see, okay, it gives me Ghana and Nigeria. So this is 0, 1, 2, 3. Okay, so let's say to 4. And when I run this, it gives me Ghana, Nigeria, and Australia. So it gives me from here all the way to 3. So this is basically going to get from 1, which we started, to the one before, which we end. So that's how to do that in Python. And then we can also get the type of the list. Now, if I print something like type countries, now it's going to print to me that this is a list down here. So let me just quickly type CLS to clear everything I've done. Now let me print it. You see it says class lists. So this is showing me that this variable type is a list. Now if it's just a normal variable, let's say a string variable, it's also going to show me that it is a string. Now let's try that. Let's just divert from list for a second, and let's say we have name. Tell me, and I say the type of name. When I run it, you see down here it says a string. If I change this to 12, you see down here it says integer. So that's how to get the type of a particular variable. So that's how we know now that this is a list variable. Now I can just simply delete that. And then let's say I want to change the value of one value in this list. Now let's say I want to change this from United Kingdom to United States. So what I'm just gonna do is to just say countries 0, because the index number of United Kingdom is 0, should now be equals to United States. And then let me just add a print. Let me print countries. Now when I print countries, okay, you see name is not defined. That's because we've removed this variable that was called name. So let's just remove this line and run it again. You see now the first value is now United States. Meanwhile, it's United Kingdom right here. But that's simply because we changed it to United States here. We can also do it again. Let's say we want to change Australia, which is the third. We'll say 3. And let's say we want to change Australia to a country like Canada. And when I run it, you see we have United States, Ghana, Nigeria. We don't have Australia again, it's now Canada, and then we have New Zealand. So that's how to change a particular value in a list. Now let's say we want to get only the end of this list. We can also get it by let me just quickly delete all this. We can get New Zealand by just typing countries with its index number, which is 0.234. New Zealand index number is 4. If I type 4 and run it, it gives me New Zealand. But I can also do it in another way. Now if I add a negative sign right here, let me delete this, and I say 1. Now this is gonna get the list from the last value in that list. Now if I run this, you see it gives me New Zealand. If I say -2, -2 is obviously Australia. If I run this now, you see we have Australia. So note that when you're using a negative sign, it gets you that list from the last, from the bottom basically. But you note that from the beginning, we use 0 for the first, and then when we're starting for the last, we use -1. Yeah, that's because, as we know in normal math, 0 is neither negative nor positive. So when we start from the back, we use -1, not -0. So when we start from the front, it's 0. When we start from the back, it's -1. So that's how to basically use that. Now there are also a lot of other things we can do with lists. Like we can get the length of this list. Now let's say we want to get how many values we have in this list, because most of the times you have a large amount of data. You can start counting them one by one like this. But you can just say len countries, which is the name of the list. Now once I run it, you see it gives me 5, which is because I have 5 values in here. But note that when it gives me the answer, it doesn't give me based on index value. Now index value is just like the ID assigned to each of these values right here. But when I calculate the length, it gives me the actual amount we have here, which is 5. But if I'm to calculate it from the index number, it will be 4. I hope you understand that. You can also do some other things, like in a list. As you can see, all of these are strings. Now instead of printing strings, let me just delete this New Zealand. Instead of printing only strings, I can change, let's say this Ghana, I can change it to a number like 2. So now we have a string, we have an integer. If I print this, okay, this gives me 4, so let me remove length. As I print this, you see it still gives me what I want to see. If I print the index number of this, which is 1, and I press run, it still gives me 2. So we can mix different data types in a list. I can also change this Nigeria to true, which is a Boolean value. As I run it, let's remove this. I run this, it still gives me that. So there is not going to be error, nothing is going to conflict. We can just easily do that. And you remember that we checked the type of a list. So right here, once I run this, you see that it gives me class list, which means this variable is a list. But let's say I want to check the type of the values in a list. Like I want to check the type of this value or the type of this value. Now, as you know, this value is a string. This is an integer. This is a Boolean value. This is also a string. Let me overrun it. You see it gives me int, which is integer. And once I overrun this, let me see. Okay, it doesn't give me anything there, but this is a Boolean value. And this is a string. So let's say I want to get this. I'll just say type countries, square brackets, and I give it its index number. Now when I run this, you see it says class is a string. Let's say I want to get for the second one, which has an index value of 1. Once I run it, it gives me integer. Let's try for the third one. It gives me bool, which means boolean. So that's how to basically get the type of a string. And we can also do some other things, like, let's say, the last thing I want to show you for this part is another way to define a string, or let me say to assign a string. I mean a list, sorry. So instead of using the square brackets, we can also use something we call lists. But now when we are using this list constructor, it's called a list constructor. It is used to construct a list. We aren't going to use square brackets again. We're going to use normal round brackets like this. But now, so let me just delete this line. Now let's use the list constructor to specify how to construct a new list. So I'll use a list, and I'm going to use normal brackets, parentheses, and it has to be double. So when I'm using the list constructor, it has to be double like this. Now in here, I can have all my values like Nigeria. I can have 34. I can have false. And once I print this, okay, we don't want to print type. We just want to print everything. Countries. Now you see, it gives me everything which I want to see. So that's how to basically use the list constructor to specify a list. So we can print a list in two ways: the normal, the second list constructor, and then we can also print with the normal way without lists, like the square brackets, like this. Let me say countries too. So now, if I say type, print the type of countries, you see it's gonna give me list. And then let me also print the type of countries too, just to show that both of them are still a list. So list and list. So that will be all about the basics of list. In the next video, we're going to talk more about list attributes. There's still a lot of things we can do with lists. In this part, we're going to be talking more on lists. Specifically, we're going to be talking about list functions or list methods in Python. So in the last part, I showed you about lists and plenty things you can do with lists, plenty list attributes. In this video, we're going to dive more deeper. Now let's say we have two lists. The first one is list 1. And this list 1 is just a bunch of numbers. 1, 2, 3, 4, 5. And then we have list 2. And then we want this list 2 to just be, let's say, a bunch of fruits. So we have banana, and then we have apples, mangoes, and then let's say oranges. So now we have these two lists. Now let's say we want to join these two lists together, like we want to print it together. We are going to do something like list 1 dot append dot extend. We want to extend it with list 2. Now once I print list 1, what this is going to give me is this joined with this. So let's print it. Right here, you see 1, 2, 3, 4, 5, then banana, apple, mango, oranges. So you just give me this joined with this. The first list joined with the second list. So that's what extend does. It combines the two lists together. But let's say we want to add a value to the ending of this list, like oranges. We want to add, what other one do we have? I think we have cherries, but we just want to add something else to these. We can do something like list 2 dot append list, let me say cherry. Now once I print list 2, it's gonna print me all these with cherry. Now cherry is part of this list. You see now that it prints me bananas, apples, mangoes, oranges, and it prints me cherry. Now if I say I want to get the length of list 2, now we have 4 here, but since we appended 1, it should give us 5. Now you see we have 5. So that's just that's a simple way to append a value to a list, and it's very useful also. But let's say we want to put in a value in between one of these, like we want to put in a value in between banana and apple. This cherry, we want it to be right here, something like this. Now if we want to do that, we're just gonna say list2.insert, and then this is gonna take 2 inputs. Now it's gonna take the index number, the index place we want to put it in 1, and then what we want to put there is cherry. Now let me explain this further. So it says list2.insert. We want to say in the index number 1, that means right here, then cherry should be right here. So 0, 1. We want it to be here. We want to use cherry. When I print this, you see now we have another cherry in between. So as an apples, we have cherry. So that is how to insert a value in between a list. But now let's say we want to remove a particular value from that list. We can say list2.remove, and let's just remove bananas. Now once I print list2, it's gonna print me list2 without bananas. And that's very easy. It's just by saying remove, then whatever you want to remove. But now let's say we want to do something like we want to delete everything in this list. Clear. List2.clear. This is gonna be empty. It's just gonna be an empty list. It clears everything, deletes all the values in there. Once I run it, you see now that it prints me an empty list. So that's how to just delete a list. Very easy. But now let's say that we have these values, and then mango, we want to get the index number of mango. As we know, this is 0, 1, 2. So the index number of mango is 2. But we want to get it. Let's say we have thousands of values in this list. We want to dot index of mango. So you're just gonna print the index number of mango. Let's just run it. Right here you see it says 2, 0, 1, 2. So it tells me where mango is located in this list, which is very helpful. Now let's say we have a value appearing more than once, so we just want to know how many times the value appears in this list. Now it's very easy. What we're just gonna say is list.count mango. So now it should tell us 1 because mango only comes in this list 1 time. Once I run it, you see here we have 1. Let me come here and input mango again. Now once I run it this time, you see that we have 2 because mango is in our list 2 times. So that's how to simply do that. But now let's say we have a list of numbers, and let's say they are scattered. Like let's say we have 1 here, and let me just delete all these. We have 4, 5. Let's say we have 3 here. So 4, 3, 5, 1. And let's have 2 at the end. So let's say we want to print this list in ascending order. You know, as I said, in Python, you might be working with a lot of data, and we have thousands of numbers that are scattered, and we want to print them accordingly. Let's say from 100, we want to print to 250 to 350 accordingly, not scattered. We we can easily do that. What we're just gonna say is list1 dot sort like this. Then right here, I'm just gonna print list1. Now once I print it, it's not gonna print it 4 3 5 1 2. It's gonna print 1 2 3 4 5 in ascending order. Now you see, now we have 1 2 3 4 5. This also is very useful when working in Python. But now let me just remove this mango. We don't want to have it twice. That was just for testing. But now let's say that we want to print a list from the back. We want to reverse that list. We want to print it from the bottom. What we're gonna do, we'll say list2 and dot reverse. It's very easy. We just say list2 dot reverse. And once we print list2, you'll see that it prints it from oranges, then to mango, to apples, and to bananas. Let's run it. Now you see oranges, mango, apple, banana. And that was how to easily print a list from the bottom, from the last value in that list. But now let's say we want to duplicate a list. Like we want to just take this list and copy it again or something like that. Let's test it for list 2. Let me delete this. So let's have another list named list 3. And let's say we want this list 3 to just be exactly the same thing with this, a duplicate of list 2. So what we're just gonna say is list 3 can be equals to list 1 or list 2, dot copy. So you're just gonna copy all the values in list 2 and then paste it in list 3. Now once we print list 3 and run it, we have exactly the same thing we get when we print list 2. So it's exactly the same thing. And then we can also do something more fun. Like let's say we just want to delete the last value from this and just print everything else. We can do that by saying, we can use that by saying the pop method. So we can just say list2 dot pop. So when we say list2 dot pop, it's just gonna remove the last value we have in that list. Let's just delete this. We're gonna remove the last value we have in that list and then leave the rest. So when I print list2 now, it should have only 3 values. So now you see we have bananas, apples, and mangoes. No more orange. But let's say we want to be specific, we want to delete. You remember that we can just remove a value by saying list2 dot remove, and then we can just specify it here. Let's say banana, and then when we print this, it will remove banana. But we can just also delete or remove a value by using the index number. So in pop, we can just say list.pop, just like pop out to remove something. Let's remove the one with the index value of 1. Let me say 1 and print. It gives us banana, mango, oranges. It gives us that same list but without the value of that index number. But we can also do this instead of using pop. We can do this exact same thing, but now we can use delete. So when we say del, I will say list2, let's say 0. So now this is going to delete the value with the index number of 0 in this list2 list. So when we print list2, it's going to give us everything without banana. Let's run it. Now you see we have apples, mangoes, and orange. I remember that I also showed you how to just clear a list, how to just delete everything in a list. We can also do this using this del function. So instead of specifying something here, if you just say delete del list2, now this thing is going to be cleared, this list. Once I run it, it says list2 is not defined. Okay, but we do have list2 right here. So let's do something like delete list1, yeah, and then let's just print. Oh, okay. So the reason why it says list2 not defined can see we have list 1. Now here we have list 2, which is banana, apple, mango, and oranges. Then what we're just doing, we deleted list 2. So once we delete this list 2, it's quite different from the one which we did earlier, which was list.clear. Remember that if we do list2.clear, it's just going to remove everything here, but that list is still going to be available in our code. But when we use this delete, it's just going to delete away that list. It's going to delete that variable. So it's not going to be in our code again. That's why when we now try to print list2, Python doesn't see it again. It says list2 is not defined. So it completely removes it. So that's the difference between the clear function and the delete function. Now that's going to be all for lists for now. In this tutorial, we're going to be talking about tuples in Python. So tuples are used to store multiple items in a single variable. So if you know list, which we talked about in the last part, tuples are very similar to lists, but they have some basic difference, like tuples are immutable. Now immutable means you can't change any value in a tuple. Now let me show you how to write a tuple in Python. Now let's say we have a tuple of 3 numbers. Let's say 3 underscore numbers. And I give those numbers, and when you are writing a tuple, it should be in normal bracket, not square brackets. So 1, 2, and 3. So let's say we have this. Now when we print 3 numbers and run that, it just gives us this tuple. But we can also do some things like get the first value in that tuple using the index number. I can say get me 0, which will print us 1. So we can also do all those type of things. But let's say we now try to change the value of 2 to something like 25. It's not possible because, as I said earlier on, it's immutable, which means we can't change it. Once we have the tuple, that's the way it's going to be for our code. We can't refine it or edit anything from the tuple later in the code. So let's say we want to do something like 3 numbers, and I would say from the index number 1, change it to 23, and then I now want to print 3 numbers. Now this is going to give us an error. So here it says type error, tuple object does not support item assignment. So it's saying what we want to do, tuple doesn't support it. So that's the basic difference between tuple and lists. And then we can also do some other things, like tuples allow repetition of numbers or repetition of values. Like I have 1, 2, 3. I can also input 1 again. When I just, let me remove this line. I have 1 twice. Once I print that, it's going to work fine. It allows repetition of the same value. And I can also do some things like I can get the length of a tuple. I can just say print len, and then it's just going to give me the amount of values we have in this tuple. As you can see, it prints 4 because we have 1, 2, 3, 4 values. And then I can also check the type just to make sure this is a tuple. Like I can do type to know if this is a tuple or not. Once I run it, you see it says class tuple. So that shows me that that is a tuple. And tuple also allows various data types. Like I can have another tuple and say strings. And then I can say home, land, let me give you one more, earth. Now once I try to print strings, you see that everything works fine. So it allows various type of data types. We can also do it again for like the Boolean type. Let's just say BOO, and then let's say true, false, and then true again. Now when we try to print BOO, you see that it works fine. So it allows various data types, and then it doesn't just allow them on separate variables, we can mix them together. Like now we have 1, I can have another one which will be a string, which will be O, and then I can have another one which is gonna be a boolean. So once I print the first one, which is 3 numbers, now you'll see that everything still works fine. So tuples allow all these kind of things. And then in tuples, we can also check the data type of the value of that tuple. Now, if we want to check the data type of this first value, we can say type of 3 numbers with the index number 0, which is the first one. So it should print us int, which is integer. So as you see here, it says class int. Now that's tuple can also do that. Now instead of just writing this parentheses right here, or normal bracket, or circular brackets, anything you want to call it is totally fine. We can also use the tuple constructor. Just the way I told you about list constructor, there is also a tuple constructor. So the only difference is just that we're going to add tuple right here, and it will have 2 brackets like this. Once I try to print everything, it's still gonna be fine. Let me just print the tuple variable normally. And once I print it, you see that it's still a tuple. Nothing goes wrong. And that's gonna be basically all about tuples, the basics of tuples in Python. So we might be using these tuples less often. In Python, we mostly use lists, but in some cases, we really want to use tuples in Python. Something like, let's say you're working with coordinates, or just some numbers that you don't want to change, or some values you don't want to change. Tuples might be the best option. In this tutorial, I'm going to be talking to you about functions in Python. So functions is just a bunch of code which perform a particular task. Now functions allows you to package your code well, or let me say restructure your code well. It's just like a block of code which performs a particular task. Then when you want to use that function, you just call it. So let me show you how to do a function in Python. So for us to define a function, we're going to use a keyword called def. Now once we type this def, Python knows that now we want to define a function. So I can say def. Let's just do a simple function which is going to greet the user, and maybe to say welcome or something like that. So we can just say greetings. So now the keyword which is def, and then after it we have greetings, which is the name of our function. So I can say greetings underscore function. So this is the name of our function, and then it's going to be followed by open and close parentheses, and then after it we're going to have a colon. So after this block of code, Python knows that whatever is going to come below it is going to be the task in which we want that function to perform. So once I click enter, you're going to notice that it doesn't start from beginning, it starts right from this place. Automatically it indents. Now in Python, indentation is very important. So now this indentation shows us that whatever code we're going to write, let's say like print something, is going to be under this function. But if I just remove the indentation and I start from here, then the function is cancelled. It is an invalid syntax, because normally there's supposed to be an indentation. And an indentation, one indentation is equals to 4 spaces. So if I go here, you can see it's 1, 2, 3, 4. So once it indents automatically, that means it created 4 spaces. Now let's say you are using a code editor which does the indentation automatically. Like if you are using Notepad, and then once you click on enter, it doesn't add the indentation. You can just add space like this, 1, 2, 3, 4. It does automatically indented. So now we want this function to just tell the user welcome, greetings from me, or something like that. So we can just say welcome user. So like this function named greetings function is printing to the user that welcome. But if I run this, nothing is done. Let me just close this up. And why is that? So when we have a function, for that function to be performed or for that task to be executed, we need to call that function. And how will we call this function? We can just say, now, once I press enter, you see it's still indented, but I want to go out of this function. I'm done with what I'm doing in this function. So I can just press a backspace. Now this is out of this function. Now if I just say greetings function with open and close parentheses, now I'm calling this function. So that means this is just the same thing as everything we have in this function. So now it should print welcome user. Once I just run it, you see now it says welcome user. So that is how to use functions in Python. But functions is more broad. There are a lot of things we can do with function. Now as you can see, this thing says welcome user, the result. But which user? Let's make it more fun, something like that. We can pass in something called argument or parameters. So right here in this open and close parentheses, instead of just blank, we can pass something like, let's say, name. Oh, not this. So name, which is the name of the user. Now instead of saying welcome user, we want to say welcome name. So right here, we're just gonna say
Hey everybody, welcome to the show. I'm Stephen Bertoni, live from the NASDAQ market site. And today we have David Jones, who is the founder and CEO of the Brand Tech Group, also an author, an activist, and he took a city bike here. So he's an environmentalist too. So David, welcome to the show.
It's great to be here.
So you sit on the forefront of advertising, branding, but also generative AI.
Yep.
You were talking about this stuff not last month, not last year, 2015, before AI was the buzzword of everything. Set the table for me. What are we seeing right now?
So look, I think you're just seeing an explosion in generative AI around the world, and I think it's going to be the biggest revolution and change that we've seen, not just in marketing but in business. And there's a few reasons for that. Firstly, you have every major global CEO of any of the tech platforms saying this is going to change the world, and we're going to spend billions to make sure it does. Secondly, you're seeing investors, saying this is the future. So whether it's Nvidia going past 2 trillion, or Microsoft going past Apple, depending on the day, on the back of AI. Thirdly, you're seeing world people saying it's amazing. ChatGPT was the fastest technology in history to get to 100 million users. And I think fourthly, it's amazing, if you play around with any of the tools, what it does isn't remarkable, but how it does it is absolutely remarkable. So, humans today can probably still create better content than Gen AI or machines. It's just you can't do it in 60 seconds. But the thing I would kind of package all of that under, however, is, I have no doubt that we're going to see just enormous change. But today, particularly talking about the advertising business, about 100% of the headlines are around generative AI, but still less than 1% of the content is created using generative AI. Now that's going to change, but we're very much at the start.
You guys recently at Brand Tech raised about $112 million. 115 million dollars American, and a $4 billion valuation as a advertising technology company. And I have to admit, I'm surrounded by advertising like everyone all day long. I'm in media, so advertising keeps the lights on and pays my salary.
Yeah.
But I don't really understand how the business works. Tell me what you guys do on a Monday morning.
So basically, probably the easiest way to describe it is we have a platform called Pencil, which is an end-to-end platform for creating advertising. So on the one side, it plugs into all of the models, so from ChatGPT to Gemini to Stability, but also some of the databases like Getty. So that's kind of on the left, which is what feeds in. And then here on the right, it plugs directly into the advertising accounts of Instagram and Facebook and TikTok for a brand. And then the platform sits in the middle, and you arrive on the platform, and very simply, you can decide what you want to do. So do you want to make a video of TikTok? Do you want to make a post for Instagram? Do you actually just want some consumer insights? Do you want to create a pack shot? And it's a workflow that takes you through that entire process, and at each step, it gives you a prediction, because it's sort of been in market since 2018. We've made over 1 million ads using generative AI, spent $1 billion of media through the platform.
You made 1 million ads.
1 million Gen AI ads since 2018. And that allows us to predict how we think a particular piece of content is going to perform. And so literally you just go through the process. You start with insights, you then start with what images you want to create, start with some headlines, it works off templates, and then you can literally publish those if you want to direct to the social media platforms, and you get live data back on how you're doing. So what it does is that there's nothing remarkable about what it does. It's just to be able to do that in one place, which as each of the Gen AI models gets better, it gets better to give you predictions and to get data back. So it's just exploding.
When you say 1 million ads, is it going to be these custom? Let's say Forbes is hiring using Pencil, and we're trying to sell subscriptions, memberships. Will a Forbes ad served to you be different than to me? Are there all these iterations, or are they kind of A/B testing what works or what doesn't work?
The thing about it is it's gone from almost A/B testing to A to Z testing, because the size and scale that you can now create content at. So you can literally just pull down, and create limitless feed variations. So if you literally wanted to have 150 different target audiences and segments, it can instantaneously create the content for you for that. One of the most, it's not necessarily that impressive, it's just impressive to watch, is when you just ask it to translate immediately into any language all of your content. And it's that speed which is really remarkable. And over, since 2018, we've been able to prove that we can make the content 10 times faster, we can make it perform twice as effectively, and we can do it for about half the cost.
Give me an example of a campaign recently done through Pencil or done through Brand Tech.
So, literally, there's literally thousands of ads on Instagram, on TikTok, and it's typically that social content, so social and digital. It's not yet, and we can come on to talking about this, it's not yet getting in, Pencil isn't yet getting into the TV side, but it particularly good around e-commerce, around performance marketing, around social, and we're working today with 50% of our top 20 clients in the space.
You've been in advertising all your life. You're like the youngest advertising CEO ever, I think.
I was once young,
yes. He's still young. So this was the 90s, correct? When you first started?
Yeah, exactly.
It's insane to think that you started this before really the internet, before mobile, before digital, before influencers. Like, how has what you did years ago and then fast forward today, how has that changed?
So look, I launched Australia's first ever internet agency in 1998. And I think we often look at today and we think it's always been like it is today, and we think it will always be like it is today, and those two things are never true. And I literally, when we launched Australia's first internet agency, we honestly never thought you'd watch a video on a computer. Now if you can't stream Netflix up in the air flying over the Atlantic, you're annoyed. If the Wi-Fi's down in a plane, it's like, what?
Yeah, you're sitting in planes to the airline.
Where 15 years ago, if someone had said to you, you'll have really high performance Wi-Fi in a plane and you can stream videos on your mobile phone, you say don't be stupid. And I think it's exactly the same thing. There is not a single thing that humans do that cannot be done better, faster and cheaper using generative AI. And that's already. And if you think about just the progress that the tools have made, if I look at Pencil, when Pencil launched in 2018, 1 in 10,000 ads, you could use. Today it's 10 out of 10. And that's where we are. Just imagine where we're going to be in 12 months. If you take a tool like Midjourney in 2022, if you ask Midjourney to create an image of a woman, it was pretty terrible. It had 7 fingers. It didn't really. 23 was not bad. 24 was exceptional. ChatGPT 3 failed the New York bar exam in 2022, passed at 90th percentile in 2023. So you've got all of these companies spending billions to make this better and better. And so the speed of progress is huge. And a few people have said, that expression that we always massively overestimate the change we're going to see in 2 years and underestimate 10 years. I think maybe not this time. I think maybe in the next 2 years we're going to see pretty remarkable change.
So this big 10x we're seeing, what does that mean for 3 stakeholders? What does that mean, A, for people in advertising that used to make this, write this? What does it mean for brands? And then what does this mean for consumers like me, who's the ultimate target, frankly, of all this? Where are we going? You said, 2 years ago, ChatGPT failed the bar exam. Now it's accelerating. The rate of change is exponential. It's so fast. Where are we going?
So look, I think for brands, it's fantastic because you are able to create your content better, faster, and cheaper. And so, it's going to basically be an amazingly powerful and significant impact in marketing and advertising. I think for creative people and people in the industry, the kind of the saying that it's not Gen AI that's going to take your job, but it's someone that's using it. I think we're going to see the greatest creative revolution in history. If you look at what the mobile phone did, it turned every single person into a content creator. Like, people now get up and create content you never would have thought of creating content before. Generative AI, it turns every single person into an advertising agency. So, there are 60 million people today employed.
Is that good for the world?
Well, maybe not, but we'll see. 60 million people, work in the creator economy today, and pretty much the same number of people work in the traditional advertising industry. Those jobs only exist because of the mobile phone. So I think we're going to see, and the reason we call Pencil is we believe that it's a tool for humans to use, not a replacement. And then what does it mean for individuals and people? Some of the things that digital advertising and marketing have done with technology are terrible. Like, we'd buy a pair of sneakers and then it would follow us around the internet for a week. Firstly, that's really annoying because I know you're following me. And secondly, I'm the last person who's going to buy that again. And so, we've done some, when I say we, not us, but the industry has done some really, really dumb things. But I think the potential for AI to actually create, a much better, more targeted and more personalized. So we talk a lot about hyper-personalization. People that hate brands, they just aren't interested in some brands or others. And they don't hate advertising, they just don't want annoying, bad, poor advertising. And if we get into the world that I think we'll be able to get into, a world of hyper-personalization, where you're going to be able to understand much more about people and target them based on what they're genuinely interested in. You can almost head to sort of the perfect market where, brands aren't spending a bunch of money annoying people. Platforms aren't creating big platforms that annoy people, and as an individual, you're actually only seeing things that you're interested in or would be interested in.
I have a question with advertising and media. So, the news media it's in a paradox. I think I'm pretty sure that people have never read more of their lives, never read more news, the history of humankind. At the same time, the model's broken. Just look at what's happening to legacy media, layoffs, startups are failing, people are moving away from free digital advertising to memberships. I could go on for hours. What does this mean for media? And could this be a positive change, or is this going to be another, big hurdle for traditional news media to, get around?
So look, I think, if we fast forward 10 years, I think there'll be way more content, and I think we will look back on 2024 and go, do you remember it was so easy, in exactly the same way as we look back to the old TV world and kind of remember. So I think the rule of history is that there will be more and more content. But I think hopefully generative AI and AI will allow us to make much more sense of that content, and whether that's us as individuals or us as companies. And I'm not sure if you saw Satya Nadella's annual letter to the Microsoft shareholders. He kind of said, and I'll paraphrase it, but we spent decades organizing data into databases, but the one thing that's been missing is the ability to kind of reason and have intelligence over that data. And I think that's what we're going to get to. To be honest, I actually think generative AI is fairly neutral in terms of its impact on media. I think a much bigger disruption was the arrival of social media, was the explosion of mobile phones, because literally everybody went from, reading a newspaper every day and sitting in front of a television to, 90% of their time spent on a device they have in their pocket. And I think that was an enormous disruption for the media industry to cope with. I think Gen AI is going to be much more neutral and will actually enable any business, no matter what you're doing, and potentially, and particularly if they adopt it super early and look at, well, how do we get ahead through Gen AI, it could be a real positive.
If you and I were, let's take a time machine way back. If you and I were 18 years old right now, in university, hoping to get into the creative worlds of marketing, advertising, you name it, what do you think we're doing in 4 years? What's our skill sets? Like, what should people looking for a future in any kind of content creation, what skills do they need, and what do you see them doing?
So look, I think, one of the most important skills today, as with any tool, is the ability to prompt and to use the tools. So I think a lot of people, sort of look at it as if this is going to like remove everyone's job, and I think that's highly unlikely. It actually enhances humans because you can do so much more. And we created a brand in under an hour, end to end, everything from the name, the product design, the logo, e-commerce assets, the business plan, the press release, and so
what was the brand?
It's going to be announced, so I can't tell you. It's basically a cat brand that gives money. It's a not-for-profit, and all of the money goes to putting girls into education. But we literally built the entire thing end to end in 59 minutes.
Okay.
And I think when you have that kind of potential, a cat brand that gives money. It's a not-for-profit, and all of the money goes to putting girls into education. But we literally built the entire thing end to end in 59 minutes.
Okay.
And I think when you have that kind of potential, actually the ability to decide and to choose becomes much more important than the ability to create, because you can create. You almost have infinite creativity. And so I would say much more about the prompting. So what are the prompting skills you need? If you put a poor prompt into a model, it will give you a poor outcome. If you put a great prompt into a model, it will give you a great outcome. So I think in the short term, prompting super interesting. Like two pieces of advice. Number one, it actually doesn't matter so much what you're doing, just be in that industry. It's a bit like getting into anything in and around social media or anything in and around the internet. And the second one is just make sure that you're playing and learning and experimenting yourself.
What role with this, you said it's a tool. What role do humans will have in the process of creating this copy, this advertising, and what do we all have to watch out for? Because there's obviously risks when you're creating content, targeting, you name it. Like, what should we be cognizant of, and where do humans sit in this kind of this timeline of coming up with a brand with the help of social media, with the help of generative AI, and then letting it go wild in the public?
Yeah, look, I think, as a few people have said, making predictions is hard, especially about the future. If you ask me where I think the future of the industry plays out, I think 70% of it is going to be very much how, the New York Stock Exchange or the NASDAQ or any of the kind of stock markets of the world play out today, where it's all automated. So I don't think you'll have humans in the loop. I think you'll have humans outside of the loop, and it will be set up to connect content, data, and media in real time. It will optimize, it will change, it will reserve content, it will create content. And in much the same way, you were in that world. There used to be people sitting on trading room floors with bits of paper and phones and running around, and no one does that anymore. But there's still a lot of people employed and doing very well in the finance industry. So I think about 70% of that is probably fully automated, and 30% will be high quality, high human involvement. I mean, we did a TV commercial in the UK for a brand called Hotel Chocolat, and it's all created through generative AI, and it was actually one of the most effective TV commercials in Great Britain last year. And so the ability to create content now using generative
It was a TV commercial.
TV commercial. It was ranked. It was ranked number 1 in the confectionery category, again ahead of anyone else, and I think it was like the number 8th most effective TV.
Was it like a
commercial.
cartoon?
No, absolutely. It's basically Hotel Chocolat as the name says on the tin, they make a basic hot chocolate. And no,
So it's not like a hotel made of chocolate.
No, it basically takes you through the whole journey of seeing the product and gorgeous chocolate and all the imagery. And it's pretty remarkable, and I think you're going to see that become rather than become an exception.
You got into this world in 2015. I mean, got into AI is going to be the future of advertising.
Yeah.
That was so early on. What kind of gave you the confidence to be like, I'm going to go all in on this technology that no one was talking about? We're talking like 6 years before when ChatGPT kind of like rocked the world and got most outlets. This was almost like science fiction. What was the kind of beacon that got you into this?
I think I've spent my career sort of seeing things come along and seeing lots of people be cynical and then seeing it become huge. So, whether it was internet in 1998 or mobile in 2011, I wrote a book on purpose back then, and then you see how something like that goes from being dismissed becomes very massive and mainstream. And I think just the potential that it had, and that doesn't mean to say that it necessarily happens quickly, but we invested in AI chatbots in 2015. We created the world's first AI chatbot for an influencer, for Kalani Hilliker.
What was that like? What was the chatbot like?
And I think this is the point. It's like if you stayed in kind of specific guardrails, it was really good. But once you moved out of that, we invested in the company called AI Foundation, who built digital humans, and they created Digital Deepak, and he went on Jimmy Kimmel, and he led a guided meditation, and it's fantastic. But
Deepak Chopra.
Yeah, but back then, this is probably 2018. Once you got a little bit outside of, what the AI was comfortable with, it kind of went spiral. We built my mind twin, and it was in a meeting with one of our clients who asked me what my purpose was, and instead of talking about a proper purpose, I said my purpose in life was to have fun. But I think whether it's AI data or AI media planning, you've seen all of these things make enormous progress.
For the Forbes, our 100th anniversary issue, we had Warren Buffett cover a whole thing. The first issue of Forbes, and it was, remember AR, augmented reality? You held your phone up, it came alive, you could ask boring questions, but again, you can only answer the very tight swimlane of questions. He wouldn't tell you the purpose of life.
But I think, and so because we've been investing in the space since 2015 and learned a ton of lessons, seeing what worked, seeing what didn't work, and I was always looking for a platform that could do end-to-end advertising using AI. And that's where Pencil and Will, who founded the company in 2018, and brought him into the fold. But I think we always look at the new technologies and are quite dismissive of them. It's sort of human nature. We don't like change. If we look at it, we think it's actually going to be a really bad thing, not a really good thing. If you look at human history, every time humans have had great technology, and I use technology in the broader sense, whether it's the wheel, fire, the printing press, and most recently the mobile phone, we've done amazing things. And I have no doubt it will be the same. There are clearly some issues that I think has an enormous potential to be a massive positive for humanity.
When you come across a new technology, or a new paradigm, if you will, do you have like a certain checklist or way of thinking about things where you're not, because you've been right about a lot of things throughout your career. Do you have a way to be like, obviously not fearful, but also not over exuberant? Yeah. Is there like, what is your, give me in your head, because you've picked a lot of winners and you've seen where the media world is going for a long time, like around corners, as the cliche goes. What is kind of your way of thinking? So you're not dismissive, but you're also not like
naively optimistic. Yes. Look, I think it's a couple of pretty simple things. I mean, we have one set of criteria in terms of when we're looking at investing, but when it comes at looking at technology in general, I think it's actually just using common sense and going, do I'm going to use this, do this, and so that's literally like the common sense radar. I think there's a second one, which is, is this pretty frictionless? We were very early investors in, I had taken credit card from a book, and at the time, John Fan said that AR would be bigger than VR because everyone had a device, and nobody thought that. Back in 2015, everyone was on the VR train, and he was right. Everyone had the device, they created a really simple game, and the world played it. Yeah. So, secondly, is it kind of simple and frictionless? And I think thirdly is, how quickly can this change? And if this changes, how big could it be? So if you look at all of the headsets that are coming out today, they're making a lot of progress. But if you fast forward and imagine every single person on the planet could have a pair of glasses that can be normal, that can be augmented reality, and that can be virtual reality, and they're absolutely seamless, and they're not that expensive. Do you think the world would wear them? And probably it would replace the mobile phone? Yeah, absolutely. Now, if it's super heavy and uncomfortable,
costs $3,000, and you look crazy dirty.
But don't forget, like mobile phones, there was a thing called Iridium, which was this giant satellite phone that worked all over the world and cost about $120,000. And then obviously we all have one of those in our pocket now, and it doesn't cost $120,000. And so I think that's the thing. I think we underestimate just how good this is going to get. And I think we will no doubt do it again with generative AI, but it's sort of been the barometer for my career, which is like, don't be stupidly naive and think, we're going to make 100% of our revenue in this year. But actually, if the technology evolves, is this something that could be completely game-changing? Absolutely.
I know you're an expert, you live in the worlds of advertising and branding. What does this jump mean for journalism, for novels, for music, for movies? What do you see the change coming? Do you see this as advertising as an early on thing, and then is this going to spread to everything?
Yeah, I think what's interesting about it, usually new technologies, the kind of, the first use case or best use case isn't content and advertising, and with generative AI it is. But I think that the most important thing to understand about it is it's a horizontal, not a vertical. So pretty much every other thing that's come, like social media is a vertical, e-commerce, a vertical, metaverse, a vertical, whereas this is a horizontal. And what that means is there's nothing that anyone in any industry does today that they can't do better than And the way around it, literally from, what are the 10 questions you want to ask me, based on everything I've said publicly for the last 10 years. You may not love exactly what it gives you, but I guarantee there'll be 3 or 4 on there for you, which you actually think are quite good. And one of my clients phoned me the other Sunday and sort of said, David, you say this phrase a lot. I've got a big presentation to investors this week. I'd love you to, just give me some content. And I spent about an hour putting some stuff together. But I also then just did a quick prompt and said, hey, give me, answer this for me. And honestly, the two together was a great combination. But what I got from ChatGPT, I could have just sent that, and they would have been really good. And I think was that hour I spent on a Sunday worth the extra versus doing that? But there's nothing that you can't get help with, which is why I think it's going to be so good.
This is moving so fast, the whole AI world. How do you stay up on how do you stay current on everything? How do you know, what do you read, where do you get like your best insights about this like ever-changing world, ever-changing AI world?
So I think the first thing is you can't. We're literally in a space.
Are you a tech person? I know you're a tech person, but are you technical?
No, I think I understand how people will use technology rather than how to build technology. So I've got a good radar for, do you think people are going to use that? Will they do that? Will they not do that? Rather than will I build it? But I think honestly, you can't keep up. And I think if you try, you'll kind of burn out. I think you want to have 8, 9, 10 sort of key sources you go to so that you're across most of the big things that are happening. But I think the other thing is just to be open-minded and talk to people. You will know 3 things that I don't know. and I'll probably know 3 that you don't know.
You're very optimistic.
No, I guarantee it. And we'll have that conversation. And I think, the worst thing you can ever do is pretend that you have all the answers and you know everything. And people who want to appear smart like to do that, but you can't. It's moving way too fast. I was literally in a plane half of last week, and you land, and enormous things have happened. So, and then I think just probably more important than that is just play with all the tools. When you see that someone's launched something, just go have a little play. Don't need to spend a long time on it, but spend half an hour so that you understand how it works and how you use it.
I think going out to play is a perfect spot to end this. I want to thank David Jones, the founder and CEO of Brand Tech Group. David, thank you so much. It's a pleasure.
Jensen Huang, the CEO of NVIDIA, took the stage at Taiwan over the weekend, and he made some major announcements, including what is his vision of the future of artificial intelligence. And a lot of it is completely mind-blowing, from AI factories to robots to digital humans. I mean, this is the stuff of the future. So I want to show you the most interesting part of his keynote. Let's watch.
Please welcome to the stage NVIDIA founder and CEO, Jensen Huang.
Intro clip, he's going to show off everything that he's going to be talking about for the rest of the video, and he says that none of it is pre-generated. It is all simulated with AI, and it includes everything from digital humans to weather prediction to completely automated factories, robots. Let's take a look.
Everything that I show you today is simulation. It's math, it's science, it's computer science, it's amazing computer architecture. None of it's animated, and it's all homemade. This is NVIDIA Soul, and we put it on to this virtual world we call Omniverse. Please enjoy.
Next, he really shows how NVIDIA has the biggest moat possible with really their CUDA framework and all of the flavors of CUDA. And if you're not familiar, CUDA is basically the library that runs these GPUs, that does this hard math at scale. And that's why it is so difficult to break into the hardware industry, because that CUDA software is a huge moat and everybody's adopted it at this point.
Accelerated computing does deliver extraordinary results, but it is not easy. Why is it that it saves so much money, but people haven't done it for so long? The reason for that is because it's incredibly hard. There is no such thing as a software that you could just run through a C compiler and all of a sudden that application runs 100 times faster. That is not even logical. If it was possible to do that, they would have just changed the CPU to do that. You in fact have to rewrite the software. That's the hard part. The software has to be completely rewritten so that you can refactor, re-express the algorithms that was written on a CPU so that it could be accelerated, offloaded, accelerated, run again. That computer science exercise is insanely hard. Well, we've made it easy for the world over the last 20 years. Of course, the very famous cuDNN, the deep learning library that processes neural networks. We have a library for AI physics that you could use for fluid dynamics and many other applications, where the neural network has to obey the laws of physics. We have a great new library called Ariel that is a CUDA accelerated 5G radio, so that we can software define and accelerate the telecommunications networks the way that we've software defined the world's networking internet. And so the ability for us to accelerate that allows us to turn all of telecom into essentially the same type of platform, a computing platform, just like we have. cuLitho is a computational lithography platform that allows us to process the most computationally intensive parts of chip manufacturing, making the mask. TSMC is in the process of going to production with cuLitho, saving enormous amounts of energy and enormous amounts of money, but the goal for TSMC is to accelerate their stack so that they're prepared for even further advances in algorithm and more computation for deeper and deeper narrow and narrow transistors. Parabricks is our gene sequencing library. It is the highest throughput library in the world for gene sequencing. cuOpt is an incredible library for combinatorial optimization, route planning optimization, the traveling salesman problem, incredibly complicated. Scientists have largely concluded that you needed a quantum computer to do that. We created an algorithm that runs on accelerated computing that runs lightning fast. 23 world records. We hold every single major world record today. cuQuantum is an emulation system for a quantum computer. If you want to design a quantum computer, you need a simulator to do so. If you want to design quantum algorithms, you need a quantum emulator to do so. How would you do that? How would you design these quantum computers, create these quantum algorithms, if the quantum computer doesn't exist? Well, you use the fastest computer in the world that exists today. And we call it, of course, NVIDIA CUDA. And on that, we have an emulator that simulates quantum computers. It is used by several 100,000 researchers around the world. It is integrated into all the leading frameworks for quantum computing, and it's used in scientific supercomputing centers all over the world. cuDNN is an unbelievable library for data processing. Data processing consumes the vast majority of cloud spend today. All of it should be accelerated. cuDNN accelerates major libraries used in the world. Spark, many of you probably use Spark in your companies. Pandas, one called Polar, and of course, NetworkX, which is a graph processing database library. And so these are just some examples. There's so many more. Each one of them had to be created so that we could enable the ecosystem to take advantage of accelerated computing. If we hadn't created cuDNN, CUDA alone wouldn't have been possible for all of the deep learning scientists around the world to use. Because CUDA and the algorithms that are used in TensorFlow and PyTorch, the deep learning algorithms, the separation is too far apart. It's almost like trying to do computer graphics without OpenGL. It's almost like doing data processing without SQL. These domain-specific libraries are really the treasure of our company. We have 350 of them. These libraries is what it takes and what has made it possible for us to have such open, so many markets.
Next, he's going to talk about what he is dubbing Earth 2, which is a completely simulated digital twin of the Earth. And it's going to be used to do a lot of things. Of course, predict weather patterns and try to prevent weather disasters. games. And then he's gonna play a demo, and keep in mind, everything you're looking at is completely simulated. Not a movie, not CGI.
This is Earth 2. The idea that we would create a digital twin of the Earth, that we would go and simulate the Earth so that we can predict the future of our planet. Disasters, understand the impact of climate change, adapt to it so that we can change our habits now. Digital twin of Earth is probably one of the most ambitious projects that the world's ever undertaken, and we're taking steps every single year. We'll show you results every single year, but this year we made some great breakthroughs this year.
On Monday, the storm will veer north again and approach Taiwan. Different paths will have different levels of impact on Taiwan.
想象一个我们能够预测未来的世界，数位孪生反映真实情况的虚拟世界，让我们看见未来。数位孪生是一种真实世界的虚拟模型，让我们用这个今天的行为来预测对未来世界的影响。介绍一下 NVIDIA Blvd， 一个利用 AI 物理模拟电脑通信技术来预测全球气候的数位孪生。Core-Diff 是 NVIDIA 的生成式 AI 模型，它在 WRF 数值模拟的基础上训练而成，能够以12倍更高的解析度生成天气模式，从25公里提高到2公里，这代表了区域天气预测的一个巨大飞跃。令人惊讶的是 ，Core-Diff AI 运算快1000倍，且能源效率高3000倍。在台湾的中央气象局使用这些模型来更精确地预测台风登陆点。让我们并不止步于此，下一个前沿是超稳定预测，能精确到数十米，并考虑到城市基础设施的影响。Core-Diff AI 还在使用像是 POM 生成的高解析度数据解析训练，一个极高解析度的物理模型，用于模拟大气和海洋边界层。当与天气模拟风场结合一起时，它可以模拟建筑物周围的气流。当极强风汇聚的情况，我们预计能够预测像下冲这样的现象。当强风汇聚到街道层，会有可能造成损坏并影响行人。NVIDIA Blvd 是一个绝佳范例，它融合了人工智慧、观测数据。可以帮助国家和公司预见未来极端天气的影响。
And now he's going to talk about what he is also calling the Big Bang of AI. So everything prior to seeing ChatGPT was all about vision and understanding, but no one really understood the capabilities in terms of generative AI. And now that is the explosion we're seeing in the world today. And he talks about the new AI industrial revolution, which is really interesting. And he references delivering software the old way, which Microsoft did, really packaged software, delivered it, and that was incredible. But now, rather than delivering software, we are going to deliver AI. We're going to deliver models. And I think he's kind of getting at the fact that developers are not really going to be building software 10 years from now. AI is going to be building software. We are going to be building AI.
Here, let me show you something. This slide, okay, and this slide. The fundamental difference is this. Until ChatGPT revealed it to the world, AI was all about perception. Natural language, speech recognition. It's all about perception and this was the first time the world saw a generative AI. It produced tokens, one token at a time. And those tokens were words. Some of the tokens, of course, could now be images, or charts, or tables, songs, words, speech, videos. Those tokens could be anything. Anything that you could learn the meaning of. It could be tokens of chemicals, tokens of proteins, genes. You we can learn physics. If you can learn physics, you can teach an AI model physics. The AI model can learn the meaning of physics, and it can generate physics. We were scaling down to 1 kilometer, not by using filtering, it was generating. And so we can use this method to generate tokens for almost anything of value. We can generate steering wheel control for a car. We can generate articulation for a robotic arm. Everything that we can learn, we can now generate. We have now arrived, not at the AI era, but a generative AI era. But what's really important is this. This computer that started out as a supercomputer has now evolved into a data center, and it produces one thing. It produces tokens. It's an AI factory. This AI factory is generating, creating, producing something of great value, a new commodity. In the late 1890s, Nikola Tesla invented an AC generator. We invented an AI generator. The AC generator generated electrons. NVIDIA's AI generator generates tokens. Both of these things have large market opportunities. It's completely fungible in almost every industry. And that's why it's a new industrial revolution. We have now a new factory producing a new commodity for every industry that is of extraordinary value. And the methodology for doing this is quite scalable. And the methodology of doing this is quite repeatable. Notice how quickly so many different AI models, generative AI models, are being invented, literally daily. Every single industry is now piling on. For the very first time, the IT industry, which is $3 trillion, $3 trillion IT industry, is about to create something that can directly serve $100 trillion of industry. No longer just an instrument for information storage or data processing, but a factory for generating intelligence for every industry. This is going to be a manufacturing industry, not a manufacturing industry of computers, but using the computers in manufacturing. This has never happened before. Quite an extraordinary thing. What started with accelerated computing led to AI, led to generative AI, and now an industrial revolution. Now the impact to our industry is also quite significant. Of course, we could create a new commodity, a new product we call tokens for many industries, but the impact to ours is also quite profound. For the very first time, as I was saying earlier, in 60 years, every single layer of computing has been changed. From CPUs, general purpose computing, to accelerated GPU computing, where the computer needs instructions. Now computers process LLMs, large language models, AI models. And whereas the computing model of the past is retrieval-based, almost every time you touch your phone, some pre-recorded text or pre-recorded image or pre-recorded video is retrieved for you and recomposed based on a recommender system to present it to you based on your habits. But in the future, your computer will generate as much as possible, retrieve only what's necessary. And the reason for that is because generated data requires less energy to go fetch information. Generated data also is more contextually relevant. It will encode knowledge, it will code your understanding of you, and instead of get that information for me or get that file for me, you just say, ask me for an answer. And instead of a tool, instead of your computer being a tool that we use, the computer will now generate skills. It performs tasks. And instead of an industry that is producing software, which was a revolutionary idea in the early 90s. Remember, the idea that Microsoft created for packaging software revolutionized the PC industry. Without packaged software, what would we use the PC to do? It drove this industry. And now we have a new factory, a new computer. And what we will run on top of this is a new type of software. And we call it NIMS, NVIDIA Inference Microservices. Now what happens is the NIM runs inside this factory. And this NIM is a pre-trained model. It's an AI. Well, this AI is, of course, quite complex in itself. But the computing stack that runs AIs are insanely complex. When you go and use ChatGPT, underneath their stack is a whole bunch of software. Underneath that prompt is a ton of software. And it's incredibly complex because the models are large. Billions to trillions of parameters. It doesn't run on just one computer, it runs on multiple computers. It has to distribute the workload across multiple GPUs. Tensor parallelism, pipeline parallelism, data parallelism, all kinds of parallelism. Expert parallelism, all kinds of parallelism. Distributing the workload across multiple GPUs, processing it as fast as possible, because if you are in a factory, if you run a factory, your throughput directly correlates to your revenues. Your throughput directly correlates to quality of service, and your throughput directly correlates to the number of people who can use your service. We are now in a world where data center throughput, utilization is vitally important. It was important in the past, but not vitally important. It was important in the past, but people don't measure it. Today, every parameter is measured. Start time, uptime, utilization, throughput, idle time, you name it. Because it's a factory. When something is a factory, its operations directly correlate to the financial performance of the company. And so we realize that this is incredibly complex for most companies to do. So what we did was we created this AI in a box, and it containers an incredible amount of software. Inside this container is CUDA, cuDNN, TensorRT, Triton for inference services. It is cloud native so that you can auto scale in a Kubernetes environment. It has management services so that you can monitor your AIs. It has common APIs, standard APIs, so that you can literally chat with this box. You download this NIM and you can talk to it. So long as you have CUDA on your computer, which is now, of course, everywhere. It's in every cloud, available from every computer maker. It is available in hundreds of millions of PCs. When you download this, all of the software is now integrated. 400 dependencies all integrated into one. We tested this NIM, each one of these pre-trained models, against all kinds of our entire install base. That's in cloud, all the different versions of Pascal, Amperes, Hoppers, all kinds of different versions. I even forget some. NIMS. Incredible invention. This is one of my favorites. And of course, as you know, we now have the ability to create large language models and pre-trained models of all kinds. And we have all of these various versions, whether it's language-based or vision-based or imaging-based, or we have versions that are available for healthcare
digital biology. We have versions that are digital humans that I'll talk to you about. And the way you use this, just come to ai.nvidia.com. And today we just posted up in Hugging Face the Llama 3 NIM, fully optimized. It's available there for you to try. And you can even take it with you. It's available to you for free. And so you could run it in the cloud, run it in any cloud. You could download this container, put it into your own data center, and you could host it, make it available for your customers.
And now he's going to talk about digital humans. And he specifically says none of it is animated, meaning pre-rendered on a computer. Not at all. It is all AI generated in real time. The voice, the face, the dialogue, absolutely everything. And he believes this is the future of how humans and computers are going to interact. And it's a little bit scary. Watch this.
We can interact with these AI services with text prompts and speech prompts. However, there are many applications where we would like to interact with what is otherwise a human-like form. We call them digital humans. NVIDIA has been working on digital human technology for some time. Let me show it to you. And before I do that, hang on a second. Before I do that, okay, digital humans has the potential of being a great interactive agent with you. They make much more engaging. They can be much more empathetic. And of course, we have to cross this incredible chasm, this uncanny chasm of realism, so that the digital humans would appear much more natural. This is, of course, our vision. This is a vision we love to go. But let me show you where we are.
Great to be in Taiwan. Before I head out to the night market, let's dive into some exciting frontiers of digital humans.
Imagine a future where computers interact with us just like humans can.
Hi, my name is Sophie, and I am a digital human brand ambassador for Unique.
This is the incredible reality of digital humans. Digital humans will revolutionize industries, from customer service to advertising and gaming. The possibilities for digital humans are endless.
Using the scans you took of your current kitchen with your phone,
They will be AI interior designers, helping generate beautiful photorealistic suggestions and sourcing the materials and furniture.
we have generated several design options for you to choose from.
There'll also be AI customer service agents, making the interaction more engaging and personalized. Or digital healthcare workers who will check on patients, providing timely, personalized care.
I did forget to mention to the doctor that I am allergic to penicillin. Is it still okay to take the medication?
The antibiotics you can prescribe, ciprofloxacin and metronidazole, don't contain penicillin, so it's perfectly safe for you to take them.
And there'll even be AI brand ambassadors, setting the next marketing and advertising trends.
Hi, I'm Ima, Japan's first virtual model.
New breakthroughs in generative AI and computer graphics let digital humans see, understand, and interact with us in human-like ways.
From what I can see, it looks like you're in some kind of recording or production setup.
The foundation of digital humans are AI models built on multilingual speech recognition and synthesis, and LLMs that understand and generate conversation.
我们有丰富的祭祀仪式和传统舞蹈，还有对大自然的崇拜。
The AIs connect to another generative AI to dynamically animate a lifelike 3D mesh of a face. And finally, AI models that reproduce lifelike appearances, enabling real-time path-traced subsurface scattering to simulate the way light penetrates the skin, scatters, and exits at various points, giving skin its soft and translucent appearance. NVIDIA ACE is a suite of digital human neutron SLM and LLM NIMs to understand our intent and orchestrate other models. Riva speech NIMs for interactive speech and translation. Audio to face and gesture NIMs for facial and body animation. And Omniverse RTX with DLSS for neural rendering of skin and hair. These NIMs run on NVIDIA GDN, a global network of NVIDIA accelerated infrastructure that delivers low latency digital human processing to over 100 regions.
Next, he's going to talk about the evolution of AI architecture and infrastructure. And where do we go from here? He's literally going to say that. And he's talking about specifically the capabilities growth of this hardware and how that growth is accelerating. So not only is the capability accelerating, but the acceleration is accelerating. Look at this.
And so where do we go from here? I spoke earlier about the scaling of our data centers. So every time we scale, we found a new phase change. When we scale from DGX into large AI supercomputers, we enabled transformers to be able to train on enormously large data sets. Well, what happened was, in the beginning, the data was human supervised. It required human labeling to train AIs. Unfortunately, there is only so much you can human label. Transformers made it possible for unsupervised learning to happen. Now, transformers just look at an enormous amount of data, or look at an enormous amount of video, or look at an enormous amount of images, and it can studying an enormous amount of data to relationships itself. Well, the next generation of AI needs to be physically based. Most of the AIs today don't understand the laws of physics. It's not grounded in the physical world. In order for us to generate images and videos and 3D graphics and many physics phenomena, we need AIs that are physically based and understand the laws of physics. Well, the way that you can do that is, of course, learning from videos to create a synthetic data, simulation data, and another way is using computers to learn with each other. This is really no different than using AlphaGo, having AlphaGo play itself, self-play, and between the two capabilities, same capabilities, playing with each other for a very long period of time, they emerge even smarter. So you're going to start to see this type of AI emerging. Well, if the AI data is synthetically generated and using reinforcement learning, it stands to reason that the rate of data generation will continue to advance. And every single time data generation grows, the amount of computation that we have to offer needs to grow with it. We are about to enter a phase where AIs can learn the laws of physics and understand and be grounded in physical world data.
And he's going to now introduce Blackwell. And Blackwell is their new GPU architecture, the future of NVIDIA, and it's pretty darn cool. Let's watch.
So we expect that models will continue to grow, and we need larger GPUs. Well, Blackwell was designed for this generation. This is Blackwell. We took two of the largest, a chip that is as large as you can make it at TSMC, and we connected two of them together with a 10 terabytes per second link between. The world's most advanced SerDes connecting these two together. We then put two of them on a computer node connected with a Gray CPU. The Gray CPU could be used for several things. In the training situation, it could be used for fast checkpoint and restart. In the case of inference and generation, it could be used for storing context memory, so that the AI has memory and understands the context of the conversation you would like to have. It's our second generation transformer engine. The transformer engine allows us to adapt dynamically to a lower precision based on the precision and the range necessary for that layer of computation. This is our second generation GPU that has secure AI, so that you could ask your service providers to protect your AI from being either stolen, from theft, or tampering. This is our fifth generation NVLink. NVLink allows us GPUs together, and I'll show you more of that in a second. And this is also our first generation with a reliability and availability engine. This system, this RAS system, allows us to test every single transistor, flip-flop, memory on chip, memory off chip, so that we can, in the field, determine whether a particular chip is failing. The MTBF, the mean time between failure of a supercomputer with 10,000 GPUs, is measured in hours. The mean time between failure of a supercomputer with 100,000 GPUs is measured in minutes. And so the ability for a supercomputer to run for a long period of time and train a model that could last for several months is practically impossible if we don't invent technologies to enhance its reliability. Reliability would, of course, enhance its uptime, which directly affects the cost. And then lastly, decompression engine. Data processing is one of the most important things we have to do. We added a data compression engine, decompression engine, so that we can pull data out of storage 20 times faster than what's possible today. Well, all of this represents Blackwell. I think we have one here that's in production. During GTC, I showed you Blackwell in a prototype state. The other side. This is why we practice. Say me, man. Just ladies and gentlemen, this is Blackwell. Blackwell is in production. Incredible amounts of technology. This is our production board. This is the most complex, highest performance computer the world's ever made. This is the gray CPU. And these are, you can see each one of these Blackwell dies, two of them connected together. You see that? It is the largest die, the largest chip the world makes. And then we connect two of them together with a 10 terabyte per second link. Okay, and that makes the Blackwell computer. And the performance is incredible. Take a look at this. So, you see our the computational, the flops, the AI flops for each generation is increased by 1,000 times in 8 years. Moore's law in 8 years is something along the lines of, oh, I don't know, maybe 40, 60. And in the last 8 years, Moore's law has gone a lot less. And so, just to compare, even Moore's law at its best of times, compared to what Blackwell can do. So the amount of computations is incredible. And whenever we bring the computation high, the thing that happens is the cost goes down. And I'll show you. What we've done is we've increased, through its computational capability, the energy used to train a GPT-4, 2 trillion parameter, 8 trillion tokens. The amount of energy that is used has gone down by 350 times. Well, Pascal would have taken 1,000 gigawatt hours. 1,000 gigawatt hours means that it would take a gigawatt data center. The world doesn't have a gigawatt data center, but if you had a gigawatt data center, it would take a month. If you had a 100 megawatt data center, it would take about a year. And so nobody would, of course, create such a thing, and that's the reason why.
In a nutshell, there are patterns. Anyway, you get a pulse of the city here at POV Films. Pulse of South Florida. This is what it is. So, it is what it is. Peace.